So in today's lesson, we are going to learn about Venn diagram. We're going to see how these diagrams are used in terms of 2 or 3 sets, and we're going to learn about the operations, how we are going to use this. From operation, we use the transition to symbol and Venn diagrams. And again, as you know, sets is one of the most important topics in maths, because this shows us how you can interact with different variables or different types of sets. For an example, you have a number of students as a universal set, for an example, in an institution. So in this institution, you have different departments, you have different classes. So that's very important for you to know how you're going to solve short problem using Venn diagram, because Venn diagram is just a relationship. It shows the interaction between the relationship of data. So based on this data we are having, we solve the problem using Venn diagram. So let's see here on the board. Here we have different sets of operations. The first one here is set B is contained in set A. So let's see the symbol of this one. Set B is contained in set A. So you can simply write the symbol of this. B contained in A. So the Venn diagram of this will be, so here we have, this is the universal set. Then inside the universal set you have B contained in A. So first you need to have A, then inside the A we have B. So this means set B contained in set A. So let's see the other one here says the absolute complement of set A. So the absolute complements, you can write it as this A bar or this symbol. Okay. So this one, we are using this type of set in terms of the universal set, which is U. So if we have here B, so A complement will just be this inside. So you can just shade this region. So it tells you that A is a complement. So we remove A in the universal sets. So the other one here we are having is the relative complement of set B with respect to A. So the relative complement is just A minus B. Or you can say A in B. Okay, so A in B, the Venn diagram of this looks like you have here A, you have B, and A. So we subtract B in A. So this is the Venn diagram. So the fourth one here, the union of set A and set B. Of course, we treat this one on our previous lesson. So the union of set A and set B, simply you can say A union B. So here the Venn diagram for this type of set is just this. So for union, of course, you know, we combine all the variables. So you will shade all the region here. This is A, this is B, so we shade all the region. This is our universal set. And the last one here is the intersection of sets A and B. So here the symbol is A intersect B. The Venn diagram of this symbol, so we have here set A and set B. These are our universal sets. So this is our intersect of the region. So from this one type of diagram, you can solve any problem using this relation, because you can just have 2 sets of data, A and B, then we can use this to solve. So now we have an example here on the board we used to solve in terms of 3 circles. So in this problem, you can see in a class of 100 students, each student in the class must offer at least 1 subject. So now you can see the 3 subjects in this class. We have maths, physics, and chemistry. So if 50 of the students study maths, let's see, and 53 study physics, and 55 study chemistry, then 20 study maths and physics, 22 study maths and chemistry, and 24 study physics and chemistry. So now we have 5 sets of questions on the board. So the first set of questions here says the number of students who study at least 2 subjects. So we need to calculate this. The number of students who study more than 1 subject. Then we need to solve this one again. The third one says the number of students who study all the 3 subjects. And the fourth question says the number of students who study exactly 1 subject. And finally, the last one here on the board says the number of students who study physics and maths but not chemistry. So we are going to solve this problem first by drawing the Venn diagram of this type of problem. Then we'll try to figure out how we are going to solve this problem. So let's see here. We'll start by drawing the diagram, the Venn diagram. So from the problem there, you see we have the universal set, which is 100. But first, let's try to draw this diagram for all the subjects and make it much more bigger so we can understand. Okay, so this is maths. This is physics. And this is chemistry. Okay. So now our universal set here, U, is 100. So now we'll start by labeling these diagrams according to the sets here. So we'll start with this. Say this is A, our A region. This is B. This is our C region. This is D, E, and F. Then this is G. But from the problem here, you can see here we have 20 students study maths and physics. So students for maths and physics, which is 20 here, is equals to, for maths and physics, we have here D plus G. Okay, because G is what is the central part of the intersection of all the subjects. So we say D plus G. This is our first equation. The students for maths and chemistry is 22. Maths and chemistry, this is 22, is equals to maths and chemistry is E, this region, then we'll add this universal. So E plus G, that's our second equation. Then students for physics and chemistry. Physics and chemistry, here is 22. And here is 24, which is F plus G. So now you see we have 3 equations on the board. But first, you can't solve this type of problem without knowing this intersection of all the 3 sets. So what we should do, we first try to find the G. Because no sooner we know G, then we can relate all this type of problem. Okay, so now we'll start by defining the universal sets U which is 100. So this universal set contains all the 3 subjects: maths, physics, and chemistry. So we equate this. Mind you, none of the students here in this class said no, I won't offer this type of subject. So any subject or any student must offer at least one subject. So if we label this part as X, this is 0. There is no students in this class that say no, me, I'm not doing this subject, I'm not offering none of the subjects. So in that note, we say this X must be 0. So now let's see, our universal set here, U, must be equals to, so now we add all these sets, these variables here, we add 50, 53, and 55, then we subtract these ones, the intersection of the subjects, where we have math and physics, math and chemistry, and this physics and chemistry. So now we start by 50 plus 53 plus 55 minus into, then we subtract the intersection of all the sets here, this one D, E, and F, minus into, we say minus D plus E plus F, okay, then we add X plus X, then plus G. You can say G, which is all the sets. So here all the sets intersect. So, but our universal set here is 100. So we say 100 must be equals to, we add this, the total. Okay, let me just say 50 plus 53 plus 55 minus, so this is 20 plus 22 plus F 24 plus 0 plus G. So this, we'll add this 50 plus 53 plus 55, which is 158. Then we subtract this one, 20, 22, 24, which is 66, plus G. So now we subtract 158 minus this, 66 is 92. So 100 is equals to 92 minus G. So therefore our G, now we subtract 100 minus 92, which is 8. So our G here is 8. Here we say G equals to 8. So from this G now we can get our variables here for D, E, and F. So here for students studying math and physics, we say D is equals to 20 minus 8. This 8 is the intersection of the 3. So therefore D is 12. So here D, we say D equals to 12. So here students for math and chemistry, which is 22, E plus G, but our G here is 8. So we say 22 minus 8 is our E. So 22 minus 8 here is 14. So our E here will be 14. Then here, students for physics and chemistry is 24. So we say 24 minus G, which is 8. So F is 16. So our F here is 16. So now from these answers we have derived from this equation, we can find this remaining parts of the problem. Here, for students studying only maths, only physics, and only chemistry. So here for maths, from the problem, the number of students that study only maths is 50 here. So now we say A is equals to 50. We subtract the number of students that study these remaining parts, okay? So 50 minus 12 plus 8 plus 14. So here now, this is 50 now minus, we add this the total. So A is 50. Let's just give the answer. Here, 50, we add this is 20 plus this is 34. So A equals to 50 minus 34. So this is 16. So our B is 53. 53 minus into, we add this one. Here, 12 plus 8 plus 16, which is 53. 53 minus 36. So this again is 17. So we come to the last one, our C. Here, C here for chemistry is 55. Say 55 minus into, add this region, 14 plus 8 plus 16. Again, when you complete this one, this is 17. So now from this problem we have solved on the board, you can see. So now back to our questions here. So the first question here says, number of students who study at least 2 subjects. So the number of students who study at least 2 subjects, so start from 2 to this one, 3. So we'll add this D plus E plus F plus G is E, D plus E plus F plus G. So if we add this 12 plus 14 plus 16 plus 8. So you add this, you have the total of 50. So the number of students who study at least 2 subjects is 50. So now the number of students who study more than 1 subject. So more than 1 subject, we just exclude this one here. Then we'll add again. So it means this question 1 and question 2 are the same. So again, we'll add this one here, D, E, F, and G. So this one again is 50. Our next question says the number of students who study all the 3 subjects. So here the number of students who study all the 3 subjects is just G. So here we say it's G, which is 8. The fourth question says the number of students who study exactly 1 subject. Exactly 1 subject. So for exactly 1 subject, we'll add this here. A, B, and C. A is 16 plus 17 plus 17 again. So this, you add this 34 plus 16. This again is 50. So now the number of students who study physics and maths but not chemistry. Physics and maths but not chemistry is this region, 12. So let's add another question here. Number of students who study exactly 2 subjects. Number of students that study exactly 2 subjects. So here, exactly 2 subjects. So for exactly 2 subjects, you add this one here, 12 plus this, 14, which is 12 plus this E. So you say this is D plus E plus F. So the number of students that study exactly 2 subjects is this one you add. You can just add 12 plus 14 plus 14 plus 16. So this one is, we add these two, which is 30, 42. So this is 42. So 42 students study exactly 2 subjects. Exactly 2 subjects. Here D, E, and F. So here brings us to the end of the lesson for today. Don't forget to give your comments, subscribe on the channel, and see you in the next video.